In the last lesson, I set you guys a test to create an application without the internet, without looking things up, just using your own knowledge, and coming up with a number guessing game. I've created my own version of this, the exact way I would write it, and we will look at that first, and then we will also take a look at some of the results that you guys produced. Don't worry about criticism, this isn't about right or wrong. This is simply pointing out the differences between how certain developers write code and how others write code. There's no single right way of how to write code. You write code that works for you, that makes sense to you, and that's easy to understand and maintain for you. The key takeaway from this test was that you created this yourself without looking things up, and you used the knowledge you currently have to produce the code. From that, I'm sure you gathered questions about, could I do this better? Is there another way to do that? Or you simply forgot certain things and you had to think about how to do them. This is a very important part of cementing what you have learned. People don't realise the importance of trying to create something yourself without re-looking up reference code or using the internet. It's surprising how much more the knowledge will sink in when you are forced to do it without those aids. I grew up writing code when the internet wasn't really a thing, and when the books didn't teach me anything useful, so this is naturally how I learn code today. I look at the basic examples, and then I start to tear it apart in Visual Studio or in the source code to understand what's going on. I rarely ever use any kind of reference material or Googling for problem solutions, with the exceptions of looking up the basic documentation about the code you are writing. If a problem arises, I try to understand it myself and solve it myself. You will see that as these lessons progress. So for now, let's quickly take a look at how I wrote this code, and then take a look at several examples from you guys, and I will point out things I think are good and things that could be improved about the code. And as usual, you are free to ignore that advice. You don't need to follow how I write code, but you can simply see how I do and choose for yourself. So let's start with my code. So this is my program. This is how I've written it. Let's just have a refresher of what we wanted this program to do. Let's press F5. You can see we have welcome contestant, take a guess what I'm thinking, any number between 0 and 100. So this includes 0 and 100. So we can guess, and we will get an output recommending whether the number is higher or lower. So I've entered 5 and it says I'm thinking of a number higher. So we can enter 66, lower. And you can see how we can try and do this to guess the number. And you keep going until you get the number right. And there we go. I was thinking 28. And it says thanks for playing. So let's take a look at how I did this. Firstly, we introduce ourselves. We say welcome contestant. Next, we create a random number. As you saw, this was the starting point I gave you to the lesson. And the way I solved this was, we want to think of it as we want to loop until, so we have the while to loop until, and we want to loop while the guessed number is not the same as the number that they need to guess. So this forms the basic loop of the program, to run until this is resolved. So until this is invalid, to break out of the while loop. In order for the while loop to run the first time, I set the guess to -1, so it's outside the range of the 0 to 100 that we want to guess. And then once we've gone inside this loop, we would exit only once the guess is equal to the number to guess, because then this would be false, and a while loop exits once the condition is false. So once we'd guessed the right number, we would say thanks for playing. We would also do a reline just so the application does not exit immediately. So the core of this application happens in this while loop. So let's take a look at that line by line. First, we ask the user to think of a number between 0 and 100. Next, we read the input from the user. And now you might expect to check for the number with perhaps int.tryparse. As you can see, I'm a developer, so I embedded a few cheats into my system. So this is something that developers often do, and it can also lead to backdoors in production software that cause vulnerabilities in applications. So you wouldn't necessarily just leave these things in production. but this is here to show you this is how developers generally think. They write the program, they have the power to change the program, and they often want little shortcuts to help them when developing an application. The important thing to remember is think about production when you come to release the application, and code like this needs to be thought of very carefully to make sure it doesn't end up in production. But more onto the fun stuff of why I made this. So, if you enter the character's cheat exactly in the console, instead of taking a guess, I will actually output and tell you the number to guess. So let's see that in action. Let's run the code, and it's saying guess a number between 0 and 100. Well, I don't want to guess, so I'm going to type cheat. And it's telling me the number it's thinking of is 3. So I can now just guess 3 and win the game. So I have a nice little backdoor here to help me cheat the system. Next up, I also wanted to potentially add a few extra features. For example, let's say we want to change up the number. This might be something that you actually want to do in the game, and not necessarily just a developer backdoor, or it could be a nice little Easter egg that isn't detrimental to the application, it simply allows you to change the number. So to do that, I simply regenerate the number to guess using the exact same line of code we did here, at which point you could decide to put this specific code into a method because you're repeating yourself. However, my preference when writing really small applications is to not overcomplicate things to begin with. Don't go breaking your code down into methods and classes and too many blocks for something that is very simple. You can see this whole application is less than 100 lines of code, so it does not warrant needing all the extra fluff. Again, this is my preference, and you're more than welcome to break your code down however you like, but me naturally writing code, I don't go and make a method for something so small. And then on top of changing the number, I decide to also output the number, which would then make this a vulnerability in production because we are outputting the answer again. So let's see the change in action, and let's also use the cheat. So we type cheat and it says we're thinking of 31. If I write change, it changes the number and says I'm now thinking of 93. So if we tried to guess 31, it's not the right number, but 93 is the right number. So you can see these are my little cheats in the system, not necessarily relevant to the application that I asked you to make, but it's something I did for the fun of it when I was writing the code, and it also gives you an insight into thinking outside the box that you don't necessarily have to do an int.try parse, and you could actually hide specific commands inside what would be expected to be just a number. So with that aside, if they haven't entered one of the cheat codes, instead, the next thing we want to do is to try and convert the data the user entered into a number. We do that with int.tryParse. So we pass in the input, which is what the user entered on the command line. We try parse, and we set the output to the guess variable. We do an if on this result because this returns true or false. So if it was successful, so if the user entered a valid integer, then we want to check if it's matching. If it is matching, we congratulate them and we break out of the loop. Now we could just specify continue here instead of break, because once we continue, the logic of the while loop would exit itself. But because I know we want to exit here, I've put break as well. This also means you could change the while loop to simply while true, but I rarely like to use while true because naturally it is an infinite loop until you use a break inside of the while loop. It also means that to somebody reading the code, it's not obvious when the while loop should exit. So this hints at when the while loop should exit. If it was simply true, then the statement while the number is invalid is completely wrong here. It makes no sense. It's simply saying indefinitely loop, and you have to scroll through the code to find out at what point the while loop would exit. So if they entered a valid number, but it wasn't the number to guess, then I output a new statement saying the number I'm thinking of is, and then I use the string interpolation inside here by using the dollar before the double quotes, using the curly brackets to now enter a code block here. And this code block basically says if the number they guessed is greater than the number they entered, question mark, which is the if, then output lower, or colon, which is then else, output higher. So this is simply saying here, again, if you wanted to break it down, cut this code out, place the letter A, do var A equals and place it in a variable. You don't need the parentheses in this case now. And we can see if we hover over A, it's returning a string, and it's returning either lower or higher based on if the guess is greater than the number. If you're still unsure of the syntax of the questionable Boolean result here, and then whether it's true or false, this statement could be further changed to, for example, string A, if guess is greater than number to guess, A equals lower, else A equals higher. So this is exactly the same statement again. And as you can see, the IntelliSense starts to suggest that we combine these into this. So it's all exactly the same. Once you are comfortable with writing the code this way, then you will find that you write this instead of the if else. And then you will also find that because you're not reusing this variable, you simply cut the variable, place it inside here, and then you will get a complaint here because it can't be used directly. We need to simply wrap it in parentheses so it can be understood as a single item inside the code block. We can collapse the if block of code using this minus here and plus to expand it. So we can easily collapse our code while viewing it to scroll through easier. So we have if the user entered a valid integer, and then we missed a comment here to specify otherwise. So we can see if they entered a valid integer, this code would run. Otherwise, it means they didn't enter a valid integer, meaning the try parse failed. And a key thing here that many overlook, and even I overlooked initially and then remembered, is that when try parse fails, it sets this guess variable to 0. So our default variable was actually -1. If we did not have this line here to reset the guess to -1, then what would happen is this else comes in, it outputs that you didn't enter a valid number, it goes down to this code block here, back up to the while statement, and it checks if guess isn't equal to the number to guess. But if the number to guess is 0, and we entered an invalid number, this logic would actually be settled because guess would equal 0, and so it would exit. So without this line, we have the invalid possibility that if the number to guess was 0 and they entered a word or a non-number value, the program would simply say, sorry, it isn't valid, but then say thanks for playing. So let's see that in action. Let's first leave it in and set the number to guess to 0. Let's guess 3. Let's guess a word, and you can see it continues, and then we guess 0 correctly. If we comment out this line that resets the guess, run it again, you can see entering 3 is correct, but this time if we enter just a word, you can see it says, sorry, but that isn't a valid whole number, and then thanks for playing, the game has ended incorrectly. So this is a small thing that many overlook, and as I mentioned, I overlooked it as well. It just means you have to pay close attention to what you expect try parse to do, and the value that you set from the try parse will always be set, and that is the purpose of the out keyword. Something the out keyword means that some don't know is that this variable will always be set. If we created a method that simply was, say, an out string my string, and we hover over the IntelliSense, we can see the out parameter my string must be assigned before control leaves the current method. This basically means that if we pass something in as an out, we can be assured no matter what happens, this method will set this variable up with a value. Always. It cannot do anything but that. As we can see here, we have to specify a value, even if it's default or null or something else. It has to be set, otherwise the code won't compile. So a hint to remember when you are writing code and calling methods, if you see the out keyword, you know this variable will get changed, and you should take into account what that value will be. So once correctly resetting it to -1, we mention that it's invalid, and the program loops. And that is the entirety of my program. Some of you may have thought I would have wrote methods, I would have broke the code down more, and perhaps that I wouldn't be cheating here. But this is genuinely how I would write the code. I don't overcomplicate things, and I don't always make things as dry as possible or as split up as possible into many methods. It's good practice when you have a production-ready application and you know exactly where you are going, and you can tidy things up and make them very modular and broken down. But often the very first run of an application, I don't do all these things. The first time you are making an application is really your first proof. You want to make the application do what you want, and you want your efforts focused on doing that. You don't want your efforts focused on breaking things down too much, writing too many methods, having to make it more complicated than it needs to be. Because there is no maintainability yet, there is no concrete application, there is nothing saying that this is going to be our final application, the final flow. So if we break these down into methods, then we decide later to remove those, we've wasted a little bit more time splitting this off into a method than just writing it as we need to. As the method grows, and once it gets much more past these 100 lines, I would start considering breaking things down into easier blocks to manage. But this application is just small enough where it doesn't warrant any kind of further breakdown in my eyes. So let's take a look at how some of you guys did the same thing. I was quite surprised that most of you wrote it almost exactly how I wrote it here. I was expecting quite a lot of variance, but I was surprised at how many of you did it so close. Let's take a look at this first example, and we can see it starts with the number to guess, and then here we have, I guess, some developer testing code left in, just to see what happens here. So I would just remove that for now to keep your code clean. And we can see this is the starting block we had. Now straight away, my slight OCD notices comments with a space, good, and then comments without the space, which seems to be a fairly common commenting practice I see. I don't like this, I like to see it separated. Again, my preference, you don't have to follow this. But one thing I would recommend is to stick with the same style. So we can see in this application we have some with spaces, some without, some with spaces. So in programming, it's very important to have consistency and standards, even when it doesn't seem important. Keeping things as a set standard really helps. So let's just go ahead and quickly correct those few things. And then we can see here another style of comment, which to me dates back to the kind of C++ days, and I used to write code like this, where comments were after the code. Here's why I wouldn't do this. It might look easier because you are not adding lines to the application, and that's almost definitely the reason why people do this. But now let's say this comment is really long, and I want to go over here, and now, oh dear, I'm at the end of the screen, and this is a wide screen. We also like to keep comments so they are legible without having to scroll left and right and left and right. So what would we do in this instance? If we go to a new line, the option is then to start doing this, which now starts to look slightly strange. So this style causes multi-line commenting to separate the else from its code block, as well as I find it distracting when you place a comment, say, on a line that's already long. You have now even less space for your comment. So I would never really preference this style of commenting. I would always place it above the line. So that's the commenting side done. Let's go back and review again. We generate the random number. We have exactly the same logic as I wrote here. We use a while loop. We loop until the number they are guessing matches the number we want them to guess. The slight difference here is for some reason it's been set to -2. There's no real reason I can see it being set to -2. It doesn't change the program, it still works, it's exactly the same. It's just a personal preference I would use is -1. I couldn't give you a good reason for that. It's simply the first invalid number that's outside of a positive number we want to guess. So once inside the loop, we then ask the user to guess a number. Again, I would add a comment here myself. And then after we've told them to have a guess, this code has integrated the console.read line directly into the try parse, which is completely fine, because once we read that value, we don't reuse it anywhere in this application. You can see in mine, however, I read the input and I kept it there because I actually use it in 3 places. So you could integrate the line like this, but again, myself, I would split this line out anyway because it's a kind of distinctive step in the application. You are waiting on the user to enter that value. So for me, and again, this is just preference, I would put this in its own separate line with its own separate comment stating that we are reading the value from the user, and then pass the variable into the try parse. After that, we have a check where the try parse is equal to true. There is actually no need for this equals true, because by default, if you specify a method that returns a Boolean inside the if, it's already expecting a true or false. So the result is already true or false. So we could remove that equals true. Again, a minor point, it doesn't harm the application, it simply makes the code shorter. Then we have a check here, which is slightly different than mine. It's more easier to follow if you are not used to doing the if and else statement combined. It explicitly states if the number's less, we tell them to guess higher. And if the value is higher, we tell them to guess lower. Again, one small point here, and my preference, if we have an if followed by an else if, I would remove the space between the two, so that this block feels like one whole block. If you separate them, it's typically for 2 separate ifs. So again, this is just a preference I have and I've done all the way through, and it's what feels right to me. Similar again, the empty space here I would remove, so my code would end up looking like this, just slightly different. And then after the try parse, if the try parse fails, we get to this else. In the else, we say you must enter a valid integer, and then we loop. But you will notice the one slight bug in the application here, that the try parse value has not been reset. So their guess on fail will be 0, and it's not been reset here. Other than that, this application is spot on. It's very well commented, very well structured, nice and simple to follow. So I would be proud of this application. This is very similar to how I would have written it, with the knowledge I would have at this stage of learning. Let's take a look at another one now. We have the normal. We have say hi to the user, enter the guess, generate the number. This user has done the exact same thing. They have set a guess number to -1. Also here, notice the lowercase r. I would start comments with uppercase. Again, it's just attention to detail and keeping things standard. We then go into a while loop with exactly the same logic. We read the line and store it as a variable. We check, and this time instead of checking if it's true and doing something first, we check if it's false and exit out. Looking at this, I would actually prefer to write my code this way, and I would go back and rewrite my code to do that. The reason being is the logic that is shorter should come first. So if they have entered an invalid number, we exit the program. This means when you are thinking through the application and stepping through, we don't have to remember that if it's true, then go through a load of code, and then come out with an else statement further down, trying to remember what the else statement was for. So I would actually prefer to write mine with the false assertion first. So if the value is not a number, they re-mention that the value must be between 0 and 100. They also correctly reset the guess number to -1, which is a good catch. And then they continue. We have an else if here. This is then followed by 3 else ifs. The interesting thing here is none of the else's are actually needed, because inside of every if, we continue, which means we don't carry on down the logic step. So we could change these to to just ifs, if, and if. You would never get here if the number was not valid, because if it's not valid, this if statement has one course of action, which is to follow down and then continue, which starts the loop again. So once we are here, we can be assured the guess number was entered as a valid integer. If the guess number is outside of the range of 0 to 100, there's only one course of action again. So when we get here, we can be assured that it is within range. So you can see that the else is technically not required here. I would not be overly concerned whatsoever about this. Changing it from if, else if to just ifs is really only a visual difference. It's not going to make the code any more efficient in any meaningful way. It's really just a high preference of whether you don't like the fact that we have else ifs. The one benefit of having else if in this case is if we change the option in here where we don't always hit the continue. We might have an option that's if something else, such as if false, something doesn't happen, we continue. Otherwise, we get to here where we would continue. So by changing this if block, if this was just an if block, it would change the flow and meaning of the application. It could now mean that we got here when the number was actually invalid because at some point here we decided to not continue. So it's just something to think about, that don't always go for cleaning up your code as much as possible, because technically right now these else statements aren't needed, whereas this code may change, or this code may change, or this code may change, and it all of a sudden means the logic further down is now invalid and you might miss that step. So my preference here would probably be to leave the else's in, because it's a clearer distinction between if this or this or this. And then we may also want to do some kind of catch further down. Instead of leaving this to overflow, we might want to wrap this in curly braces, continue, and then also have some kind of catch here for when nothing is settled, when it's an unknown state. And you can see the logic basically checks for whether the number is within range, whether it's higher, whether it's lower. And then when done, very good, you guessed the number. It doesn't have the read line at the end, so the application would instantly close if it wasn't run in the debugger. But that's again a minor point. So overall, very similar to how the last one was written and how mine was written, and very good code. Nicely commented, nicely structured. Let's take a look at another now. This time, we have the use of methods here. So we have a while loop, and nothing more than a while loop, that simply checks the user's guess and continues until this method returns true. Then after that, it mentions that you've guessed correctly. So the logic here is to make a while loop while the number was not guessed correctly. The only feedback I would have here is the name of this method is probably a little bit confusing. We are saying, if we read the code, while the check user's guess is false. But this method is doing more than checking the user's guess. It's asking the user for their guess, then it's checking it, then it's returning whether it was true or false. So the method has multiple purposes. It seems small, but it's asking the user for the input, and then it's checking against that. Instead, I would probably ask the user for their input in the while loop and pass this result into this check user input method. But other than that, you can think of this application as running this one method in a loop. So we come into this method, it asks the user for their input, which is another method. So we take a look at that. And then here, we set the user input to an unsigned integer of max value. And then while the user's input is greater than 100, and there's no need to check if it's less than 100 because it's an unsigned integer, it can't be. We ask the user to take a guess, read the value, try to parse the unsigned integer. If it's correct, it sets the user input to that value. Otherwise, it asks them to enter a valid number, and then it returns that answer. So to me, the flow of this is a little bit harder to understand. It's a little bit over confusing. The reasons being, we have an unsigned integer that by default won't allow a less than 0 value. So this is something that when we see the while loop, we are only checking for 100. We have a slight bit more pause for thought of, well, hang on, why is it not checking for less than the range? We want to check the range given. This range given may not always be between 0 and 100. We could change our code to allow guesses between -10 and 100. If we do that, this entire code has to be rewritten. This has to change type, this has to change logic, and the check has to be completely rethought about. Also, at a glance, people may not notice the uint, and they might be thinking of an integer, and they are wondering why there is a missing check for the lower range. So that slight confusion to me just adds a little bit of mental thought requirement. And then the way this if-else is written is not separated, and the comments all in one line. I would split this down into 2 lines, and I would change the comments to have comments as we discussed, similar to this, so we can read easier. And I would have it more like this. Again, another reason I wouldn't ask the user for the input like this is we now have a while loop here and a while loop here. So instead of combining a single while loop to tackle one problem, we have multiple combined while loops. So this method to me is just a little bit harder to read through, a little bit more complicated than it needs to be. After we've asked the user for their input, we then set up a variable to false, is number guessed. We then check if the user guess is greater than the number to guess, and if not, output on this line. So again, what's happening here is there's too much compression. There's long comments that are tackling multiple lines of code, and then there's the lines of code combined. This is harder to visually read and break down and scan through for me. Again, my preference is to separate these onto their own lines, and to not combine them this way, and to separate the comments. Other than that, this program does function and it works, but to me, as you see, you enter the program, you start to read, and to understand the program is much more work than the original examples. Instead of it being presented to you in one nice flow that you can read through and understand, you're having to see there's a while loop that's waiting for a false assertion to then output this. And then we go to this, and we've got another method that we have to go into, and then there's this with a while loop. And by the time you've got to this part, you've forgotten what the part above is doing. So this is an example where I would say is the downside to separating code too much. In a simple application where it simply isn't needed, this program is much harder to understand than the previous examples. Now this isn't a criticism, and it doesn't mean you should change the way you write your code. If this is how you write your code, and you are used to breaking down the code into methods all the time, and you are used to single line if statements, there's nothing wrong with that. The code works. But for me, and the way I learn code and the way I write code, I would find this harder to understand and not flow as easy as keeping it simple where it can be simple. So let's take a look at one more example. We have many, but I'm just going to take a look at one more for now. And we can see here we have the application entry point main. And now we have guess me as a new guess me. So many of you won't have seen this yet. This is a class. So we have made a class called guess me, which we know so far. We have made a variable called attempt and a variable called I, and then we're asking them to guess a number. So initially, my very first comment would be, we need comments. We don't know what attempt is. We have no idea what I is. That is not a descriptive variable name. It's always good to make your variables descriptive. And we have a class that is not really meaningful. It doesn't give us any information about what the class does. It says guess me. I guess in a way it does. It's telling you to guess me, so it's guessing something. But the lack of comments here straight away means that I have to start trying to form a mental picture of what's about to happen and what use these values are going to be. Next, we enter a while loop until we break out explicitly. We read the user's input and we store it as a string. So again, my preference would be to change this to a var. There is no need to state string. We then increment the integer I. We try to parse the value, and you can see already as I'm reading this, I don't really know. I know what should happen, but I don't really know what is happening yet because there are 0 comments. I'm having to just read this code and go back and forth and try to figure out the flow and make those comments in my head mentally to understand what's about to happen. So comments are really important and are completely lacking here. So if there's one thing I would do with this application, it would definitely be to comment more. So carrying on, we know so far that we have a class and some variables. We are stuck in an infinite loop, and we are reading the user's input and incrementing every time we do that. We then try to parse the user's input. If they entered a valid number, we check if is matched, which is fairly explanatory. We're going to check if a class being passed in matches a number being passed in. So it's not exactly explanatory because we've now passed a class and a number, and we're checking if those two things match. If they do, we break. Otherwise, we say it doesn't match and carry on. So I can kind of understand this flow fairly easily with the fact that we are now trying to match the number entered with a class called guessMe, and we yet have any information about this class. Let's just check this method is matched. Again, there are no comments, so I would comment this code to make sense. And now we are using the class guessMe with a method compareTo, which is part of an interface for comparators. So we are storing the result also as an integer instead of a boolean, because a compareTo can be used for things like sorting, where it not only indicates if the value is actually the same, but whether it's greater than or less to the value. We check if it is the same, meaning 0, and we return true if so. Otherwise, we have a string variable. If the result is greater than, we set it to less. Otherwise, we set it to bigger. And we then output this code. So already we can see there's a use of a class here with a use of a compareTo, which then comes into this class, which has an iComparatable interface, so it can implement compareTo, and then it compares the number with the one passed in and returns the result. When the class is created, it generates the random number. So I won't go into this class and the use of it, but as you can see from here, it's simply far more overcomplicated than needs to be. It is making use of things like classes, comparators, and interfaces for no real reason. I spoke to the person that wrote this code, and we had a discussion as to why. And the answer is something that I hear a lot from developers, and it's something I want to warn about, as that he felt like he had to do this. It was a requirement when writing C# code. We should use classes, we should use interfaces. If we're comparing something, we should use an iComparator. This thought pattern of needing to use certain methods or methodologies or interfaces to write your code a certain way is a really bad thing to get into your head. It's all good writing clean code, organized code, dry code, split it into methods and break it down easy. But absolutely none of that matters if your code is harder to understand, harder to maintain, or not legible for developers. You can write a program that is a single file with 10,000 lines in that functions amazingly, is super efficient and super easy to follow. Or you could write that same application with 300 classes, much more separation, that's far easier to unit test, comment, and maintain and grow, but ultimately the monolithic single class with all the code in may actually be better in some circumstances. If there's a single developer working on it and they understand that code easier, and there is no known future requirement to ever use unit testing, there is no expectation to ever document this publicly and expose it, or perhaps the code is so volatile that it's changing all the time because it's a prototype, then a single large class is a far better solution. Sticking to the rules will lead you down a path where you won't gain as much knowledge. The fear of saying you're doing it wrong or this isn't the right way is what puts many developers off. As you will learn from me, don't be afraid to do things how you want. Don't be afraid to do things that others tell you are wrong. Do what feels right to you, what makes sense to you, and what helps you write your code the way you need. So if this user finds this way easier, then they should write it this way. However, I don't think that was the case here. They created a class and created a comparator because they thought that was what they needed to do. Instead, they could have just written the code in one block and it would have worked perfectly. So I guess the lesson I'm trying to give here, don't be too concerned about breaking code down into methods and making sure you don't repeat code. As you can see in my example, I repeat the guess and I just repeat this code here twice. It doesn't matter, it's a small program, it's very simple. It's easier to do this and this than it is to make a method for this. Just write code in the cleanest way you know how that makes sense to you. Once the application grows, you would naturally find that actually now you are struggling to understand the code or to find parts of your code, or you've repeated this code 6 or 7 times and you need to go back and change it because you've changed the overall guess. And that requirement then to separate this into a method will come naturally. You will find the reason of why you need to make methods and why you need to make classes by not doing that. If you carry on making this program and we make 10 different cheat codes and we go through this and do it 10 times, and now I come and say, change this guess to between 0 and 50. We have to change this to 51, then we change this to 51, this to 51, this to 51, and we forget to change this one. We now introduce a bug into our code. We find the bug, we go through, we notice that this is a problem, we change it again, and we start looking and going, well, actually to change that so we don't have a bug, why don't we just remove this and turn it into a single method so we only have to change this in one place. That will then be the reason why you made the method, and you will understand why you made the method and you will appreciate the reason for it. If I tell you now to make this a method right now with one line, even better without the cheat code there's only this line. If I tell you to put this into a method, some people will be thinking, why? Why have I just made a method when I can just set a number? And that's a valid point. It's probably because the other developers recommending that have simply had the experience where they know in future this is likely to need a method. But the thing is, it doesn't need a method right now, so don't make a method. Don't do things just because they may be needed in future. Keep your code as simple as possible for now, and as it grows you can always refactor and make it cleaner, as you get that requirement, not before. So overall, I hope you guys enjoyed writing your first application with no help, using your own knowledge, and that you learnt things. Feel free to also comment on this code here, where you feel I could have done things different. It's simply far from perfect, and you can suggest the ways that you might have changed my code, and I can give you feedback as to whether I think I would do that, and if not, why I haven't done it a certain way. Next we'll move on to a much larger application, and you will really start learning things about C#, including classes, which are a big part. So get ready to further your knowledge, and keep this application as a memory of where you started, and look back on this further in the course to see how far you have come.